Well, thank you. My name is Ryan Jones, and today I'm going to be presenting KURLs. Let's see, here we go. Okay, so first, a little about myself. My name is Ryan Jones, and I have been a developer for over 20 years now. I started my development career with Flash ActionScript all the way back when it was still Macromedia. Then I picked up PHP and JavaScript. Next, I moved on to ASP.NET with C#. And I spent quite a lot of time there before landing on Node.js and TypeScript. And of course, anyone that knows me as of recent knows that it's all Docker, Docker, Docker. I've been with Epsilon for 5 of these years, working in the Chicago office on the UI engineering team. This is formerly the Digital Media Services, or DMS, and this is under Mark Rozier. Outside of my professional career, I enjoy home remodeling, which is good because I literally just entered in a contract for a new home. I'm an avid Audible listener, asking me about some of my favorites, and I love golfing, biking, and running. Lastly, and most importantly, I am the proud father of 4 amazing children, Bryn, Peyton, Killian, and Quinn. Now, before we get started, unfortunately, we couldn't afford to have this air during the Super Bowl, but we've got a quick commercial spot that I'd like to show you now. So I'm gonna let that roll.
Do you have logs piling up? Are your containers running out of space? Do you have garbage collectors knocking at your container doors? Do you know if you even have log rotation? Need help? We're KURLs, and we're here to help. Call us today at 1-800-55-KURLs. That's 1-800-555-8757. With KURLs, we can help you learn to love your logs again.
I love it. But really, if you are running your applications in containers, please tell me you are not writing and rotating your own logs. Okay, the big question, what is KURLs? For some, it may not feel that long ago. And for others, you may not have even been born yet. But back in 1994, Jerry Yang and David Filo, while attending Stanford University as graduate students, founded Yahoo as a curated hierarchy of links for all the best of the World Wide Web. You only needed one bookmark. From there, the entire web was only a few clicks away. KURLs is sort of like that. So let me talk about our environment. We are running Docker Swarm for our container orchestration. Now, this could very well be Kubernetes instead, or Amazon EKS, or Fargate. In our case, for now, we're using Docker Swarm. And we are running traffic as a reverse proxy for all inbound web requests. Again, this could be Nginx or HA proxy or another load balancer. But for now, in our case, this is traffic and we're happy with it. Next, we are using FileBeat to ship our logs over to Elasticsearch. And then we're using Kibana for accessing and visualizing our data. Next here, we have an example of one of our Docker swarms. It's an 8-node cluster. 5 of the nodes are managers and 3 of the nodes are workers. Again, we are running traffic to handle all of our inbound web requests. We have it configured to produce the web request logs we require, including responses with status codes, duration, and more. Traffic then proxies the request to the appropriate backend containers. For example, say we have an API request to a service running 3 replicas. Traffic is aware of the service and its 3 containers, and will route the request to the next available container. The service may in turn write any error or info directly to standard out or standard error, and this will be managed into file by Docker. Next, all of the logs produced by traffic as a result of the web requests and all of the application logs captured by Docker are automatically shipped over to our main Elasticsearch cluster. And lastly, of course, we're accessing the log data using Kibana. So we just looked at an example of one of our production swarms. we have a total of 8 swarms of a similar setup. These are currently comprised of 51 total nodes. They host 131 unique stacks. And these stacks are made up of over 250 plus total unique services. I say plus here because this number seems to grow on a weekly basis and will soon be out of date. And lastly, all of this is developed and supported by more than 100 people from various engineering and QA teams. Now, a little bit on the log volume produced by this environment. In total, on an average day, we see about 6 million web requests made to our swarms. These include all production, all stage, as well as QA, anything running in the swarms. The applications, in turn, log an average of over 60 million events per day. Again, this is captured by anything written to standard out or standard error. So the log volume is large enough where you could otherwise be looking for the proverbial needle in a haystack. Now, here is an example of our web request logs. You can see the request method and path, response status and duration, and there are many, many more metrics available. An example of the application logs. Here you can see the stream being written to, be it standard error or standard out, and the message as written by the respective service. Now, before I actually show you what KURLs is, let's clarify the problem we're trying to solve. Whether it's an issue in production or even QA, how do I quickly and efficiently find what I need from my logs? I've got 2 short clips I'd like to show you to fully bring home the problem that KURLs is solving. I'll play these in 2 times speed so we don't waste too much time. And keep in mind, I know what I am doing and I'm clicking fast. So this could take longer for anybody else, right? So first up is we're going to look at our application logs. So obviously I'm going to go to Kibana. I'm going to select our space. Once the space loads, I got to go to the Discover tab and select our index. Next, I need to filter for our stack. So I got to find the field for the stack. And I got to enter our actual stack name. Next, I need to adjust my time range. And lastly, I'm selecting the columns that I want to view, and all before I'm now viewing the logs. Now, in real time, that took nearly 1 minute. Next up, we're going to look at the web logs. So again, we're going to go to Kibana. We have to select our space. Again, we're going back to the Discover tab, selecting our index. Now here I have got to filter for our backend names. I'm going to have to look these up in our traffic dashboard. So I'm going to go to grab the front end client backend name and the front end gateway backend name. Then I need to go to our internal traffic dashboard and grab the internal service backend name. Once I've got those, I again need to filter for the time range and for the columns that I want to view. So I'm grabbing request line and the downstream status line. And finally, I'm looking at our logs. Now that in real time took nearly 2 minutes. So what did we just see there? Click, 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 right? When you are accessing your application logs without the assistance of KURLs, it takes a total of 5 steps. You're selecting your space and your index. You're filtering for your stack, and you're adjusting your time frame and selecting your columns. This takes a total of about 1 minute, right? When you're accessing your your web logs now, that is 6 steps. Again, selecting your space and your index, but now you're looking up backend names and filtering on backend names. Now, the stack that we just looked up had 3 services. If your stack has more, this is going to take a lot longer. And lastly, of course, you're adjusting your time frame and selecting your columns for a total of about 2 minutes. So how long does it take to do the same thing using KURLs? 10 seconds. Now I need to talk about the savings. When you're accessing the application logs and web request logs, and you're not using KURLs, you need to perform each step in series. So 58 seconds plus 118 seconds is 176 seconds. With KURLs, you're simply clicking links which can load in parallel. So a 10-second page load plus a 10-second page load is still only 10 seconds of time spent waiting. That's a total savings of 166 seconds every time you need to access your logs. Annually, that 166 seconds, even if you're only accessing your logs once per day, times 5 days per week, at 48 weeks, I'm accounting for some holidays and time off. That's 11 hours a year. KURLs saves you 11 hours a year. Now, I want to pause here because it's really about more than this, right? This savings is no doubt incredibly valuable, but there's something else. If it is painful to pull up logs, and let's be honest, 3 minutes is extremely painful. If something is painful, people are going to avoid doing it. Now the code, your code maybe, that's running in QA, could be logging warnings or even errors, and nobody checks because of the 3 painful minutes it takes to pull up the logs. That production incident, where users are not able to log in. People are scrambling to find the right logs. 3 minutes is painfully long when it critically matters. Now, if we are hesitant to spend the 3 minutes it takes just to pull up our logs, do you think we're going to open the logs for the services we integrate with? Today, we work with microservices spread across swarms and data centers. We have disparate teams spread all over the globe working on interdependent systems. By simplifying log access to essentially a click of a link, we reduce that barrier to entry. It now takes only 10 seconds to check your logs. And it only takes another 10 seconds to check the logs for the services you integrate with. Now, if everyone is checking their logs more frequently and are checking the logs of their dependencies, I think we can resolve many production issues sooner, or even reduce the number of potential issues before they're ever released to production. And now, I want to show you KURLs. We're going to start with the beginning. KURLs began as a simple means to an end. I wanted to stop wasting time looking up service and backend names and simply start accessing the logs. So the first things added were links to the logs in Kibana for some common time ranges. Here you can see 1 hour, 4 hour, and 24 hour. You can see all the stacks, all the services, and links to the application and weblogs. And thus was the origin of KURLs. But we grew KURLs into something more than just links. We created a platform. We added a new feature called versions, and with versions, users could gain visibility into their stacks. They could get a near real-time picture of all their deployments, including integration, QA, stage, and production. We also added badges, and with badges, we're helping to promote best practices. Finally, we wanted to merge these two views together. And so now I'm very proud to be presenting KURLs v2. This is it. This is the UI. It looks great. It's fast. We have access to all the stacks and all the services. And it's packed full of useful data and links that are updated in near real time. And as I keep scrolling down, you can see the magnitude of stacks and services available via this platform. Now here, this is our new zip application. It has a client, a gateway, and a service. Pretty traditional stack, right? At a glance, we can view the update config or the rollback config, the restart policy, or even the health check. We can see all the versions deployed across all the environments. We can see integration as the latest and greatest, and it sort of cascades to show the last version deployed to production. And I can click on any of these environments to see the details, when it was created, when it was last updated, and its deployment status. And of course, we have access to the logs. We have the application logs, we have the web logs, and recently we added a much requested feature to include application links. Users can now include environment-specific links to their website, Swagger docs, or anything else. And these are not configured in KURLs, but within each application's own source code. So this is just more configuration as code. And I can now click into the application logs, the web logs, the website, or the Swagger docs. It's all just a few clicks away. And got signed out. So these will take the full 10 seconds to load here. But once we get in and we see the application logs, if we wanted to quickly filter down and just say, hey, I want to see, is there something going on in the Airstream? Can quickly filter for that. Now, a lot of people are very familiar with Kibana and the Elk stack, so they know the power of this, how simple it is. With the web request logs, I can come in here and say, hey, there's some 400 messages, right? What's going on? I want to take a look at those. I can quickly filter for those. Again, the website, Swagger docs, it's all available. Now, this is zip. If I come back up here, KURLs is in here as well, right? Everything, every application, every service that's deployed automatically becomes available here. KURLs is here. Yesterday, Nate gave a talk on the client and internal authentication. All of this is available here. I can, if I'm integrating with his service, I can come in and check the web logs here. And it's all just clicks away. This is KURLs. So, in summary, KURLs saves 11 hours a year per person. We are seeing great reception with KURLs. People just love saving time, right? But you know what? I bet people actually spend more time in their logs now, preventing issues from making it to production or resolving production issues that much faster and easier. And again, there's no setup costs. Every service deployed to our platforms enjoys the same benefits for free. New applications, new deployments, and new links are all automatically added in near real time. And there is such a high value for interdependent systems. Not only do we have access to all the logs for the services we support, but we have access to all the logs for the services we integrate with. And there's high visibility across the board. We get an immediate, holistic view of all deployments for all stacks. So thank you. It's been an honor. And a special big thank you to Patrick McDonald and Michael Neely, developers on KURLs. And with that, I will open it up to Q&A.
Thanks so much, Ryan. All right, the questions that we have coming in. So how can KURLs be used by other teams? How can we expand this?
Good question. So right now, again, KURLs is, if you're deploying to any of our swarms, it's automatic. You get it for free. There's a lot of teams under the the GUI engineering. Martin earlier showed a slide for the contributions to open source or inner source, and he showed like 90% contributions come from your local teams. 9% comes from close nearby teams. I completely related to that, with people being hosted in our swarms. 90% of all the services in there are immediate services, but we actually opened that up. We are hosting maybe that 9% from some of the ad serving teams. We have a lot of their services in there as well. And then we have like that 1% that comes from those teams that are further away. I don't know if people that are familiar with the Dime project or Luna from the creative team. We're hosting some of that in our swarms as well. Now this can be taken outside of just our swarms. Again, I mentioned that this is Docker Swarm specific right now, but it could very well be Kubernetes or something else. So if somebody else is doing container orchestration, we could do something similar to bring that out. But right now it is automatic if you're deployed within our platforms.
All right. How long did it take you to implement KURLs? To build it? Build it.
Sure. It came in iterations. The first iteration, was just like a quick and dirty. We, tired of looking up backend names and going through those monotonous steps, right? So, I think there was like a day or two of like a quick hackathon type approach and just getting something working. That was, limited to a single application, right? And then, trying to make it reusable. Then, we took it and we, did a little side project and made it more repurposable, reusable across the teams. And that's where it really opened up. It's really just started last fall, and it's gone through these 3 iterations. This version 2 is really like the big broad appeal that we just launched a week ago actually.
Oh wow, okay. All right. Can you or other teams subscribe to error log messages to serve up the errors found?
Yeah, so this is to really navigate into the error logs. We are actually currently integrating the Prometheus stack to better handle the monitoring and alerting. Excuse me. And what that's going to do is that's going to allow you to say, hey, yeah, I want to subscribe to something. I can create this monitor or alert. In this Prometheus platform. I'm sure there's others that are using this or familiar with this. So yeah, KURLs isn't going. We're not gonna build any of that into KURLs. This is just gonna be, again, kind of like Yahoo origin. It's links. You can come in there. You can get to your logs easier. You can get to the application easier. You can get to the website or the Swagger docs. Again, those Swagger docs was a huge deal because everyone's got Swagger docs and nobody knows where they're at. So this is a way to consolidate that.
Great. Any plans to integrate save dashboard views into KURLs?
Yeah, well, we actually do support. I don't know if I kind of demoed it, but I didn't really demo it. So when you type in one of those searches, you can kind of bookmark that. So it updates in the URL. So it supports deep linking. So if you have a stack that you want to always go to, you can bookmark that stack and that'll be your view. But yeah, that's a good idea. Again, yeah, we're fully open to suggestions and ideas. This is our platform that we want to build and expand upon, and anything that we can do to save off seconds. You can see how those seconds accumulate and add up annually. And so that's what we want to do.
It's a great point. Did you consider other tools? If so, why did you choose this over the others?
So we didn't find, we've been using the Elk stack for a while. We could certainly, previously I was creating dashboards and saving views inside of, Kibana, right? But, and we're very happy with using our Elk stack, right? It aggregates everything for us, and the search is fast. And so we just needed a quicker way to get in there and no manual intervention, right? If you deploy a new service, and we're deploying microservices, you see there's hundreds of them now, right? So what we didn't want to have to do is have to configure a new dashboard or save new views and manually go through any configuration steps in Kibana. This is just creating the links and deep linking into Kibana into your stacks or services real quick. So yeah, we didn't find any off-the-shelf products that immediately filled this need for us.
All right, great. What would happen if the curl dashboard? What would happen in the curl dashboard if a specific swarm ceased to exist?
So we currently scrape every few minutes and grab the details. If a swarm goes offline, which it's a strange edge case. I suppose a data center could go down, right? what would happen is it would no longer appear in those results because that would no longer be part of the scrape. If we wanted to persist that and say, hey, we need to, not remove things, we could certainly do that.
Okay, great. All right, looks like we have time for one more question. What effort does it take to set up KURLs for a new application?
So again, new application deployed is going to automatically appear within minutes in KURLs. So you deploy it to integration or QA1, any environment within our Docker swarms, it's going to show up there. So you just deployed a new application and you want to see the logs for it, and maybe it's not starting up or maybe it's acting funny. Within a few minutes, it's available in KURLs, and you can quickly navigate into your logs.
All right. Looks like, I'm sorry, one more.
Sure, no
so can KURLs dashboard be used for other Kibana deployments? The one PC customer is using.
PC is
People Cloud customer is using.
Oh, okay. Yeah, again, I don't know if People Cloud is container-based or container orchestration, if it's Kubernetes or something of that sort. We don't support it yet, but it's something where it could certainly be adapted and modified, because we do have plans to move to Kubernetes ourselves. So it's going to be on our roadmap to modify this and update that. So again, I don't know if that's the case there. This is KURLs is really geared toward container orchestration, where it's scraping these systems that know all the metadata about, in our case, it's Docker Swarm, so it's stacks and services, but in Kubernetes speak, that could be pods as well. So yeah, hopefully that answers the question.
All right, great. Thanks so much. Thanks so much, Ryan. Appreciate your time and presenting here today.